Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at one of the most prominent sorting technique, which is merge sort. A brief explanation on the logic, how it works, and followed by Python code for the same. Using Python language, I'm going to explain you how to write the code for merge sort, how to convert the logic or the pseudocode of merge sort into an executable program in Python. Let's start with what merge sort is. Out of all the sorting techniques that we have in our hand that we generally learn in data structures like bubble, insertion, selection, quick and merge are the two sorting techniques, that is arrangement of data in ascending or descending order, which follow divide and conquer. That is, they divide the data into halves at every step and they merge them, especially in merge sort. It divides the data in such a way that it is broken into tiny pieces. So each and every data piece will be at a single as if you construct a tree structure for that list, all will be leaf nodes. The data points will be leaf nodes. Then you start attaching two elements at one moment and merge them to get the final merge. The best, worst, and average. All the three cases, its complexity is big of n log n, right? And it is a stable one. The basic drawback, let me get that to you. The drawback with merge sort is it needs an extra space. Suppose your list size is, the list of the elements which you need to sort is of size n, then you need an extra space of size n. The final list you are going to get in this extra space, right? So the time complexity is lower, but its space complexity is very higher when compared to the remaining sorting techniques. The sorting is quite easy, but space it requires more. So the memory which it uses is n, where n represents the total number of elements in the list which we need to sort, right? So let me explain you what merge sort algorithm says, which I'm going to develop into a Python program. So it says if there is only one element, just quit saying that there is nothing to sort. But if there are more, then divide them into pieces, two halves, right? And then merge the smaller list into a new sorted list. I can say more precisely, the sub lists which you get after merging are sorted, right? So the final list will be a sorted list. Let's have a look at a small animation of the same. Okay, so this is the pseudo code which I am going to develop into a program. Okay, here it is having two functions basically, merge sort and merge. Right. In merge sort, this is the first procedure which we are going to use is the merge sort, where it is going to divide the given list into two halves, list 1 and list 2, and recursively I'm going to call or send list L1 to the merge sort itself. It is recursive one. That means a function which calls itself. It is going to call itself. Recursive, the left side and right side are going to call itself and further divide. Once they all get scattered and divided, using merge function, I'm going to merge them all. And here goes the merge function, which says that compare the elements. Compare the elements in the two halves and merge them to get a semi-sorted list, right? So this is the basic pseudocode of merge sort, right? So let me explain you with a small example. Here you can see that this is a small list of unsorted elements, right? So now the variable start will be pointing to the 0th index, whereas end will be pointing to the maximum index, right? So I'm going to break this list into half. Have to break this into the list. It will have very simple. Have to get M. M is equal to start plus end by 2. What is the value of start? 0. End is 8 by 2, which is 4. So the element pointed at fourth index will be my center element, which acts as a barrier between the left half and the right half. Very good. Then have to merge them, right? Compare the element pointed by I and J. Then what are these I and J's? These are the variables which are going to point to the first element in the left list and the first element in the right list, right? So have a look in the picture. So I is pointing to 2, whereas J is pointing to 3. You can see that with this condition, you can clearly see that as 2 is less than 3, the element pointed by I is having a lesser value. Move that value to the temporal, right? As I said, merge sort needs extra space, right? So 2 is been shifted to the temporary, and temporary list is pointed or regulated by the variable k. As its first index value is being filled with 2, increment k. As the value pointed by I is used, increment I. Do not change the position of j, as we have not used the element of j, right? So the next move will be, have a look at this one. Now I is pointing to 4, j is still pointing to 3, right? Let's compare which element is lower, because I want an ascending order list as my final list, right? So the element pointed by I is 4, whereas pointed by j is 3. That means the element pointed by j is lesser one compared to the element pointed by I. So this time j has won the battle. So the right side list has won the battle. So bring that element to my temporary list. Okay, so I have copied the content of the j pointer into this list. That is a temporary, right? So now, as the element at the j is used, increment j pointer, and as the element at k, which was vacant earlier, is been filled, even move k pointer, increment it. Do not touch I, because the element at I is not being used yet. Okay, now the current positions is, have a look. So I is as it is there only. It is at 4. Coming to j, it is pointing to the new element 5. Let's again compare. The element pointed by I is 4, whereas pointed by j is 5, as 4 is less than 5. It means now I has won the battle. As I has won the battle, copy the content pointed by I into your temporary list. As the element pointed by I is used, increment I. As the vacant place pointed by k is filled, increment k also. Do not touch the element pointed by j, because it is not yet used. Okay, so after these changes, the new look will be like this. Now I is pointing to 6 and j is pointing to 5, right? Now let's compare the elements. 6 and 5. 6 is greater than 5. Now the element pointed by j has won the battle. Okay, so now 5 will be copied to the temporary, right? So I have copied content of j to temporary. Now as the element pointed by j is used, I'm going to increment j, so that it will is going to point to the next element, and the location to which k is pointing to is filled, occupied, even that is incremented. Do not touch I because the element pointed by I is not yet used. Right? So now the current scenario will be like this. I is pointing to 6, whereas j is pointing to 7. Right? I is pointing to 6, j is pointing to 7. 6 is less than 7. Now I has won the battle. As I has won the battle, 6 will be copied to temporary. Okay, as 6 has been copied to temporary, the element pointed by I is used, right? So let I point to the next element, which is 8. As the vacant space pointed by K is already used, so increment K also to point to the next location, empty location, right? So the new look will be like this. Now I is pointing to 8, whereas j is pointing to 7. So I is pointing to 8, j is pointing to 7. So the element pointed by j is lesser. So this time j has won the pattern. So copy the element pointed by j to temporary. Right? So I have copied 7 to temporary. As the element pointed by j is already used, increment j so that it will point to the new element, and increment k. Do not touch I because its element is not yet used. The new position will be like this. I is pointing to 8, j is pointing to 10. As 8 is less than 10, I has won the battle. Right? So copy the content of I to temporary. So as the content pointed by I is used, increment I, okay, increment k, do not touch j. Once we do this, so now I and I is pointing to 9, which is already being pointed by m. What did I tell you? M acts as a barrier between the left and the right lists, right? So now I has reached the boundary. It is standing on the boundary, right? So the element pointed by I is 9 and j is 10. Smaller is I. So copy the content of I, right? So as the content in I pointed by I is being used, you have to increment I. But if you increment I, you're going to cross the boundary. As I said, from 0 to 4, it is the left list. From 5th to 8th, this is the right list. So if you increment I, you're crossing the boundary of your left list. You're going to, I is going to point to index value 5, right? So as it is crossing its limits, so the process, the first while loop in your pseudocode ends, right? It ends. Now the point is, as I have crossed its boundary, but J did cross its boundary. Unless you do not process or touch all the elements in your list and place them in its right position, sorting is not yet done. J is holding a value 10, which is not yet been placed in your final list, which is temporary. So do the same process. Copy all the content in the right side of the list unless you reach the boundary of the right list. So 10 is copied into the final list. So the final sorted list is present in the temporary list. Okay, guys. So this is a logical expression. I will explain you what is the pseudocode and a small animation of the same. Right? Let me explain you the same using Python code. Guys, this is the Python environment where I'm going to write the Python code for merge sort. Please do follow me and follow the steps. First of all, let me create a new file. Okay, this is a new file, right, in which I'm going to write my merge sort. Okay, then let's start. The first and the primary prerequisite for a list to be sorted is the number of elements you want in that list, and the second one is the elements itself, right? Let's write the code for the same. The driver, the driver input, enter the number of elements. Right. So I have entered the number of elements, the statement for number of elements. Then I would like to read the list. Let ARR be the array, a short form of the same, be the list. Close it. Now I just want to put a constraint. See, any number of elements you can give and the list is going to take. It will not be a problem. But my point is, I want to put a constraint saying that as I have pre-declared that n is the size of the list that I finally want, I'm going to use a slicing operator to slice the same. This slicing operator will help me to slicing operator which will help me to read only n elements. Only n elements. Even after that you give, it is not going to consider. Right? So for that purpose, I'm going to use a slicing operator. Next. Then goes my function called merge sort. Merge sort, to which I'm going to pass. There are three parameters in my merge sort, right? The first one being the array name, second one being the lower index, third one being the upper index, right? So these are the three parameters which I'm going to pass to merge sort, right? So once the process is done, merge sorting is done, finally I'm going to print the result. That is the sorted list. And the final sorted list will be present in my array, right? So I have completed my driver code. So I'd like to go with the functions, the basic functions which are required for merge sort. Let's do this. Merge sort is the primary function, as there is a function which I have called in my driver code, right? What this function is. So this is going to have, as I said, the start and the end. These are the terminologies which I'm going to use. The array, the starting index, that is the lower index, and end, the upper index, that is the last index, the highest index value. Okay, to that, if the condition starts, till when I'm going to run this is till my start is less than end. That means the lower boundary is having a value less than the upper boundary. Until unless I reach that condition, I'm going to repeatedly call this merge sort. How? By calculating the mid. As I have explained you in the theory part, this is how I'm going to calculate my mid. Start plus end divided by 2, which will give me the index value of the mid element. As the lists are broken into two halves, so the first merge sort call will be with the array, the start and mid, right? And the second merge sort will have the same array, but the index values will be mid plus 1, comma end, right? So with this pieces of code, that is from start to mid, from mid plus 1 index to end, I have divided the list into two halves. So this I'm going to repeatedly do until unless I reach a place where I can no longer divide them, right? So one, that means I have divided them into pieces, into single units. Once I have done that, I'm going to merge them. To merge them, I'm going to write another function, and it will be merge. To that, I'm going to pass all the parameters that I have in my hands. The first one is the array which I would sort, the start, that is the index value 0 basically, end is the highest index value, and the mid, right? All these things I'm going to pass. So as merge is a function which is supposed to be defined before this one, I'm going to take some space and I'm going to define over here. Merge, right? So ARR, start, mid, then end. Okay, so this is the function basically. So let's write the code for this one. So in the temporary, I'm taking a temporary list. As I've shown in the animation, a temporary list will have a size equal to the number of elements in the primary given list, right? So that many elements I'm going to take in my temporary list. So, and they all are, and all the blank spaces are filled with zeros. So whenever I bring a new element to bring an element from left side of the list or the right side of the sub list, I'm going to overwrite this 0 with that element. Okay. So what is the size of it? End minus start less 1. Okay. So this is the size of my list. I think I have used an extra bracket for this one. Yeah. Now the job is done. Clear. Right. So once I have declared, I have taken an array, temporary array. I'm going to take 3 variables, I, J, K. I is a variable which is going to hold the first position of the left list. J is the one which is going to hold the index value of the first element of right, whereas K is going to hold the first index value of the temporary list, right? So let's initialize them respectively, I, J and K. So I will go with start, J will go with mid plus 1 and K will go with a 0, right? Then next. So let's start doing while I is less than or equal to mid and J is less than or equal to n. The conditions. I'm talking about the boundaries, the left and the right boundaries. The left list's boundary is mid and the right list boundary is end, right? Until unless either any one of them, if they reach the end, the sorting will get halted over there. Okay, so that these are the conditions. If ARR of I is less than or equal to ARR of J, then content in, it says that the content pointed by I is less than the content pointed by J. So copy the content pointed by I into temporary. As we have used the element pointed by I am going to increment I and I am going to increment K as well. Right? So else, that means what if the condition fails? If it is not the case, then the value pointed by J will be placed at K position. Right? So as the element pointed by J is used, increment the J pointer as well as the K pointer. Right? So this is the loop which is going to run until unless either one of the lists comes to an end. There may be a case where one of the sublists have reached their end, whereas the second part did not reach its end. In that case, we have to copy all the content left over there into the final list. For that, we need to first, let's check. We do not know whether the left list has come to an end or the right list has come to an end, because of which the first while loop is broken, right? So I'm checking if the index value which I holds is less than or equal to mid, means there is still some content in the left list. So copy it. Temp of K is equal to ARR of I, increment I, increment K. This I'm going to do if because if the condition says that there are few elements in the left list which are left. This condition fails, there is another case which is going to help me, which says that J is less than or equal to end until unless J has not reached its end. I'm going to copy all the content leftover elements in the right side to my temporary list. So temp of K is equal to ARR of J followed by J plus is equal to 1, K plus equal to 1. Right? So this is the basic logic which is used to perform merge sort. Have a look at it, guys. So I have considered the two cases where I'm going to check or run from the left list till its end and even the right list till its end. If one of the lists ends its list sooner than the remaining one, I'm going to copy the remaining content in that remaining list into my final. Right? So thereby I'm going to get a sorted list. Right? Right. So once I have done this, I have to copy. So for I in range of start and list 1, this is the list which I have, right? The range is from start till the end, right? All the elements I have to pass to array, right? ARR of I is equal to temp of I minus start, right? So this is how I have copied all the content which is present in temporary to my primary list. I have overwritten it. So let me save it with the merge sort with a name merge sort. Okay, let me run this. So let me take a set of say random 8 values. So let me take 5, 4, 6, 3, 7, 1, 2, 1, and 8. There are 8 elements. Let me check whether my code is going to execute or not. So it got executed. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this got executed. Yes, guys. So let's have a quick run towards the code, right? So this is a basic driver code which tells you how to read a list with having a limit, right? Having a limit on it. It is using the slicing operator. I'm going to do that. Then comes the function call of merge sort. Merge sort will be called using 3 parameters. One is the array, followed with the lower index and the upper index. In the merge sort, I'm going to divide using merge sort. I'm going to divide the list into halves. Divide for division purpose. As this whole algorithm, that is the merge sort, is based upon the roots of divide and conquer technique. I'm going to do the basic division part in the merge sort. Once I do that, all the bits and pieces, I'm going to use merge sort algorithm to merge them. So yes, there is no need to put a comment over there because it literally means to merge them. So I have taken a list which is of the same size of the given list, whatever the size of n may be. So I have declared the size, and then I have taken the 3 variables I, j, k to hold the index values of left list, right list, and the temporary list respectively, and I've initialized them. And the first while loop is going to run unless either one of the list come to an end. If one of them comes to the end, as the 2 conditions are concatenated with the logical operator end, the loop breaks. Once the loop breaks, then I can understand that, or you can understand that it is broken because one of the lists have come to an end, either left side or right side. We don't know which one. So we know that the one which did end is still having elements which are sorted, which needs just a copying of them into the final list temporary. For that purpose, I have used 2 while loops. One to check whether the left list has come to an end or not. And the second one is to check whether the right one has come to an end or not. It is evident that either one of these loops is going to work, not both, because the first while loop ended because of one of these conditions. Okay, so the second or the third loop is going to work. Then I have copied, because I'm having that sorted list in my hands which is stored in temporary. I just copied that content into array and I returned back to the place who called me. Totally, once I revert back, I'll reach the driver code which is going to print the final sorted list. And this is the merge sort, and you have seen the output of the same. I hope you understood this logic and try to implement it. Understand it, guys, first of all, the logic, and then try to implement it by your own. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.